Okay, again, okay, when we have a questions, we put all together the information that available here into the circuit. So we draw the circuit, the related circuit. Okay, all information here we put into the circuit. 30 horsepower, 240 volt of rated voltage, 110 ampere of rated armature current, 1200 rpm of rotational speed. This one happen usually at no load. So the armature resistance 0.23 ohms, and all together you put inside the circuit. So we have drawn the circuit of separately excited DC motor. 2.23 ohm of RF, RE, RS here, RF here, all together inside the circuit. Then we see what are the question, which is first calculate the rotational speed at no load and full load condition. Okay, when we go back to the circuit, the first thing of all is that we need to find the IF here. So we draw here for this IF. So here are IA and IL. So this is IF. So we find first what is the amount of IF. So first we try to find what are the parameters at no load condition. At no load condition, at no load, the amount of I that comes into the motor is actually 0. So IA is equal to IL, which is 0 at no load. And at this time, IF is equal to VF over RF. Even though we have 0 current from the load, still at this operation, at no load condition, we have current that feed into the field, which rotate the motor at 1200 rpm. So the amount of RF at this time is VF, which is 120 volt divided by RF of 165 ohm. So you will get 0.73 ampere of IF. This is the amount of field current when there is no load condition, 0.73 ampere. Okay, usually the motor, it comes with magnetization curve, and this curve comes with the datasheet of your motor usually. So we take a look at this IF here at 0.73, 0.7, 0.8. So 0.73 is between 0.7 to 0.8. So if half here is 0.75, so a little bit down. So 200, let's say 210 divided by 2, 205, or 210, 0.73, 200. Let's say we take it 210. So when we refer to the graph, we shall get at 0.73 ampere goes to 210 volt of EA. So we get EA is equal to, this is EA naught actually, EA naught is equal to 210 volt. This is the first parameter that we're able to find from this IF. Okay, also happen here is that VT at this no load condition is equal to EA plus IA RA. But at this time IA is equal to 0. So VT is 240 volt is equal to EA. So this is EA at 0. So EA not. So this is the second parameter. So this is EA at no load. EA at no load. This is EA not. This is EA at no load. So this is EA of no load condition. Okay. And also we know that the relation between internal generator speed with the flux and also the speed and transient voltage and the speed is represented by this equation. Is that at EA1 depend on S1. Same goes to if we increase to EA2, so we produce the same or depend on the same flux of S2. So divide by both of this equation, so we cancel the constant and also the flux, and it remains as EA1 equal to and S1 divided by S2 EA2. Okay, from this equation we are able to summarize that EA, which we calculate just now, EA no load divided by EA not is equal to N of no load divided by N naught. So we have just now, which is EA naught is equal to 210, meanwhile EA no load is equal to 250 volt, and N at no load is equal to, just now we calculate N of no load is, we have, it's mentioned here 1200. So what are the N naught here? So N naught is equal to 240 divided by 210 times 1200 and invert. So we shall have N naught sorry, this is N naught, this is N naught. So we have here and no load, this is 500. So N no load is equal to 1371.43 RPM. So this is the parameter that we should take note on. And next we go to the just now we calculate on the full no load condition. Next we will calculate on the full load scenario. So at full load, full load, IA is equal to IL and equal to 110 ampere. IA is equal to IL, flows through the armature with 110 ampere. This is the full load condition. So for this loop, Vt is equal to EA plus IA RA. Now IA is equal to 110 ohm, 10 ampere, sorry. So we put in the related value. 240 is equal to EA full load that we are looking for, plus IA, which is 110. RA is 0.23. Now we have to plus with the series value of 0.02 ohm. So you solve for this equation, you get EA at full load is equal to 202.5 volt. So this is the next parameter. Just now we find for the no load. Now we try to find for the full load. EA of full load. Next, we try to find the speed at full load. Speed at full load. So speed at full load is equal to EA full load divided by EA naught times speed at M naught. Okay, EA full load is 212.5 divided by EA naught, which just we calculate just now, which is 210, and I naught is 1200. So speed at full load is calculated as 1214.29 RPM. So this is the parameter that we calculate for the question number E. Rotation speed at no load and full load condition. So at no load, we found that the speed of the shaft is 1371.43. Meanwhile, at full load, the speed reduced to 1214.29. So next, the question is that what are the speed regulation at full load condition? What are the speed regulation of the motor itself? So the speed regulation you can calculate based on the amount. So B is that what are the speed regulation? So speed regulation is equal to speed at no load minus speed at full load. Because full load, the speed already reduced, divided by speed of F at full load times 100%. Just now we calculate the no load 1371.43, at full load 1214.29 divided by 1214.29 times 100. So it's equal to 12.94%. So this is the